All right, Math1, we are looking at some more of this solving multi-step equations. So this is review kind of at this point, so I'm just going to kind of go through the process of some of these for those of you that still need it. I'll probably mostly be working on just the odds, but I'll try to go through at least a handful of these in about 10 minutes or so. So remember that we can move stuff on either side of the equation. We can also combine things that are in common. So when I look at this first one, it says 4n minus 2n equals 4. And I noticed that the n's I could combine. And if I put those together, that would give me 2n equals 4. Then it's a pretty simple divide both sides by 2, and n equals 2. Okay, piece of cake. All right, let's look at the other one. The next one, number 3 here. Remember, I'm just doing the odds. So this one, a couple of things. First, I see that I could combine these x's. That would give me 3 equals 3. And then we got 1x minus 5x, which should be minus 4x overall. Then I can move this 3 over to the other side. That would give me negative 3 plus 3 equals negative 4x. Or more simply, 0 equals negative 4x. At this point, you can use some reasoning, or you can do a little bit more algebraic stuff. But either way, you wind up getting x equals 0. Okay, so there's those. Let's scroll down and look at a couple more of these. And here we go. Let's see if we can scroll down. There it is. All right, let's do 5, 7, and 9. So first starting with 5. It says negative 12 equals 3 minus 2k minus 3k. The minus 2k minus 3k would become negative 5k. Then we still have this 3 and equals negative 12. I'm going to go ahead and take this 3, move it over to the other side. That would give me negative 3, negative 12 equals negative 5k. These two combined would be just a negative 15 overall equals negative 5k. If I divide both sides by negative 5, then I'd have, well, negative 15 divided by negative 5 would just be 3. And on the other side, 1 over 1 is just 1k. Easy. Piece of cake, right? Let's keep going here. Number 7. I see this negative 3 on the outside, and it would be helpful if I could distribute or ungroup that right side. So negative 3x would be the first term when I distribute the negative 3 multiplying. Then I would get minus 6 equals 6. At this point, we're looking to see if we can get just the x terms by themselves. So I'm going to take this negative 6 and move it over here, which would give me 6, a positive, because it was negative on the right, now it's positive on the left. So I have 6 plus 6 equals negative 3x. That's 12 equals negative 3x. We divide both sides by negative 3. 12 divided by 3 is 4, but the positive divided by a negative is negative 4. And so negative 4 equals x. There we go. Let's keep going. Number 9. It says 24 equals 6 times negative x minus 3. So that's not 6 minus x minus 3, it's 6 times each of these terms. So we'll have 6 times negative x is negative 6x. And 6 times negative 3 is negative 18. And altogether that equals 24. From here I'm going to add 18 to both sides. So I'm going to add 18 over here and add 18 over here. That moves it over to the left side because this is going to make a 0. So I have 18 plus 24. That should give me 42 equals negative 6x. Now it's that division. So I'm going to divide both sides by negative 6 because I can make a 1 with negative 6 over negative 6. 42 over 6 is 7, but the positive divided by the negative is negative 7. So negative 7 equals x. Piece of cake. All right, so we're about halfway through our time. We're about halfway through these examples. Let's see if I can get in here. There we go. Let's just scroll that way. Awesome. So number 11, these examples are getting more complex, but that's okay. First, I see that there's a 3 on the outside that's going to distribute to both of these terms. Let's start with that. The 3 distributed would give me negative 3, and then negative 3 times 6 is going to be minus 18r. and I have 14 minus r, like that. Okay, now I want to move a lot of stuff. First, I'm going to take this negative 18, I'm going to move that over to here, and that would give me negative 3 equals 14 minus r plus 18r. Now I'm going to take the 14 and move it over to the other side. That would give me negative 14 minus 3 equals negative r plus 18r. Now I can combine a whole lot of stuff. So on the right side, negative r and 18r is going to give me 17r, because that's like negative 1 plus 18. On the left side, I have negative 14, negative 3, that's negative 17. This conveniently divides for us. It's pretty easy here. If we divide both sides by 17 to make a 1. But on the left side, the negative divided by the positive is going to be negative 1 equals r. All right, and now we see 13. We'll probably go ahead and finish from here, and from then on, after that, is most likely going to be some bonus type problems. They're definitely high end. Okay, so I see this 4k, 2 times 5k, minus 6, a whole lot of things going on, but let's go ahead and ungroup this middle piece here so I can start moving around things. So I'll have negative 4 times k plus, and then right here this is going to give me a 10k, and then 2 times 6, 2 times negative 6 I should say, is negative 12. And we got equals negative 3k minus 39. Okay, what can we do now? It looks like we can combine these two. Let's start with that. That would give me 6k, because it's negative 4 plus 10. And we have minus 12. And then on the right side, we have negative 3k minus 39. I'm going to go ahead and move the 12 over here. That would give me 6k equals negative 3k minus 39 and then plus 12. Now I'm going to move the negative 3k over to the other side. Altogether that gives me 3k. We're kind of splitting our work here. 3k plus 6k equals negative 39 plus 12. And then combining both sides, you would get 9k on the right and 39 minus, it's a difference of 39 and 12. So that would give us negative 27. And then if you divide both sides by 9, it looks like this will go in pretty evenly. K, because we have 9 over 9, that just leaves us with k on the left. And on the right side, it's going to be k equals negative 3. There we go. All right, so we're going to stop there. The rest will probably be bonus. And I would still take a shot at them because they're not as hard as you would think, just longer. Same steps, just more of them. All right, that's it for this.